Okay, the factor rating model and the cost volume analysis model are good ways to evaluate specific sites and see which one is more appropriate for our new facility. But what if we want to sort of just determine the general location of a new facility and focus primarily on transportation costs? If that's what we're interested in, or if that's something we want to consider, then we want to apply a model such as the center of gravity model. A center of gravity model is going to focus pretty much exclusively on transportation costs. We're going to determine the location of our primary demand and supply sites, basically our suppliers and our customers. We're going to look at the ones that have the heaviest and more expensive, costliest annual shipments, and we're going to try and locate our new facility in the general area of those sites that have the costliest annual shipments. So what we need to do first is have some sort of grid over the area we're considering locating in, and that also covers the area where our demand and supply sites are. And the grid will have an east-west dimension and the north-south dimension, and what we're trying to figure out is the values x subscript nu and y subscript nu, where x represents the east-west coordinate of the new site and y represents the north-south coordinate of the new site. So we're going to have these coordinates x and y, east-west and north-south coordinates for all the existing demand and supply sites. So we want to determine the coordinates for the new site we're trying to locate. So let's suppose that we have the east-west coordinates for each of the existing demand and supply sites I, and the north-south coordinates for each of the existing demand and supply sites I as well. And we also know the annual traffic volume, or annual flow of traffic between our new site that we're proposing to locate and each of the existing site I's. Right? We have a total of n existing sites. Again, that's both the demand and supply sites. And we may not be considering every single possible supplier and customer, but we're primarily looking here at the ones that we anticipate doing the most expensive business with, expensive in terms of shipping costs or transportation costs. Well, if we know what those east-west coordinates are for each of the existing sites, and we know what the annual traffic volume is for each of the existing sites, and the formula to find the general location of our new site, both in terms of an east-west coordinate and a north-south coordinate, is fairly straightforward. We're just going to take weighted averages of the east-west coordinates and the north-south coordinates for the existing sites, and those weights will be determined by the amount of traffic we're already shipping to those sites. So again, this is the first time you may have seen the summation notation in this class. You've probably seen it in other classes, but this little squiggle here, that's just a sigma. That's an uppercase Greek letter, and it's a sigma as the Greek letter S. S stands for sum or summation. So this just says that whatever is to the right, which is all this stuff right here, we're going to add up starting with I equals 1 and going all the way up to little n. Right? So in the example we're going to see here in a second, little n is going to be 3. We're going to have 3 existing demand and supply sites. So for each of those 3 sites, to determine the east-west coordinate of our new facility, we're simply going to multiply the east-west coordinate of the existing facility times the annual traffic volume of that existing facility for I equals 1, 2, and 3 for each of the 3 facilities. Add that up here in the numerator, and then in the denominator I'll add up the sum of the traffic volumes for each of the I equals 1, 2, and 3 existing facilities. Divide the numerator by the denominator, and that will give me my east-west coordinate. And then I'll do the same thing over here for the north-south coordinate. Okay, so in our simple example here, we have 3 existing sites, and these could be suppliers or customers or both. And I've established a grid with a reference point, and I'm measuring the distances to the existing sites off of that reference point. So that reference point is off to the south and west of all of the existing sites. And then here in these two columns, I'm measuring the east-west coordinate and the north-south coordinate of the existing sites, at least the distances from the existing sites to those reference points. And these numbers here are in terms of hundreds of miles. So existing site 1 is 200 miles east of the reference point and 200 miles north of the reference point. Existing site 2 is 400 miles east of the reference site and 400 miles north of the reference point. And similarly, the third existing site, either a customer or a supplier, is 600 miles east of the reference point and 200 miles north of the reference point. Over here, I've got the annual quantity in terms of tons of product being shipped or expected to be shipped between each of these existing sites and my current, or my proposed facility, I should say. And if we take a look at a diagram of where these three sites are located based on their coordinates here, we see existing site 1. Down here it's 200 miles north and 200 miles east of the reference point, which is off the map down here to the left and below. Existing site 2, okay, right here, 400 miles east and 400 miles north of the reference point, and existing site 3 way over here to the east, 600 miles east of the reference point and 200 miles north of the reference point. So obviously these three sites here are in a triangle, and it's going to make sense to put my new facility somewhere in the middle of the triangle. But if we take a look at these numbers over here that show how many tons I expect to ship between the existing sites and my proposed new site each year, clearly it looks like I'm going to want to put the new facility closest to the second site, because that has the highest anticipated shipping volume between it and the new facility. So a second site again is right up here. So we'd expect the new facility to be up here a little closer to the second site than to either the first or the third site. Well, let's apply the center of gravity model that I showed a couple of slides ago to see how that works and see if that indeed yields the result that we're expecting. Up here at the top we have the same data that I just showed you on the previous slide. No picture. We'll go back to the picture in a little bit here, but what I've got is the equations, exact same equations that I showed you a couple slides ago, okay, to determine the east-west coordinate and the north-south coordinate of the new facility. So again, we got these summation signs. We're adding up a bunch of stuff. N is, little n here is 3. I got 3 sites. So I'm adding up in the numerator to find the east-west coordinate of the new site. The product of the distance of the existing site from the reference point times the quantity being shipped to that between that existing site and my new site. Adding that up across all of the 3 sites. So if I take a look here, what I've got in the numerator, to find x new, it's simply 2 times 1,000 plus 4 times 2,000 plus 6 times 1,000. Okay, that's in the numerator. In the denominator, I just add up the total quantity being shipped between my proposed new site and all the existing sites, 1,000 plus 2,000 plus 1,000. So I do the math there, okay, and I end up with a nice round number of 4. So it looks like I want to put my new facility 400 miles to the east of the reference point, basically about as far east as existing site number 2. What about the north-south coordinate? I apply the same basic math, only now I'm applying it to the north-south coordinates of the existing sites as opposed to the east-west coordinates of the existing sites. So I get 2 over here times 1,000 plus 4 times 2,000 plus 2 times 1,000. That's what I'm basically doing in the numerator here and following this equation. And then the denominator, as you can see, is the same as in the formula for finding the east-west coordinate, simply the sum of the shipment quantities across all three sites, 1,000 plus 2,000 plus 1,000. And when I take that quotient, divide the numerator by the denominator, I get a nice round number of 3. So what does that look like? If I go back to my graphical representation, right, here's my new facility right here. Right. So these are the existing facilities. Again, we saw that site number 2, existing site number 2, that had the most being shipped to it, or from it, or between it, I should say, between that and my proposed new facility. So this distance should be the smallest compared to the distance between my new facility and existing site 1 and existing site 3, where I'll be shipping less, I expect to be shipping less material between those two existing sites and my new facility. And we can see that is indeed the case. The new proposed facility right here at 400 miles east and 300 miles north of the reference point is closest to existing site 2, much closer than it is to either the first or the third existing site.